Okay, so we're going to talk about solving linear equations by graphing. Last time you learned how to graph, now we're going to talk about how to solve using those graphs. So when you're solving equations, you're always looking for a value that makes x true. And so we're looking for values x and y to make those statements true. And those things are called roots. So let's remember we start with some formula, and you may see it as fx equals mx plus b. That fx just means function of x, and it's the same thing as y. Okay. So if you see a y in the equation, great. If you see the f of x, that's fine too. Just know it means the same thing. And those answers we're looking for are called the roots. Those are the values that make the statement true. Sometimes those roots are also called zeros. Okay, so, and why they're called zeros? Well, let's look at that. If we have 2x minus 8 is my function, to find what values make it true, I'm going to set it equal to 0 and solve. So you know to add 8 to both sides. These cross out. I have 2x equal to 8. Divide by 2. X equals 4. So x equals 4 is a root or a 0. And it's called a 0 because we found it by setting this equal to 0. Similar to the zero property type thing we had been working with. But if we chose to graph y equals 2x minus 8, that same equation, we would come up with some similar answers just by looking at a graph. So I'm going to draw my coordinate plane. And I'm looking at my y-intercept, -8. So I go down, let me count by twos, -2, sorry, -4, -6, -8. Where's that line? Oh, we'll just ignore that line actually, because erasing it apparently doesn't work very well. So I'm going to draw my point on -8 because that's my y-intercept, and then I see my slope is 2, so I'm going to go up 2 over 1. Now remember I counted by 2's, so I'm going to go up 1, 2 over 1. 2 over 1. Up 1, 2 over 1. Up 1, 2 over 1. And then I will draw my line through there. Looking so much better today. And lastly, label the line. And if you look at it, we knew my y-intercept was at 0, -8, where x is 0, y is -8. And let's look at my x-intercept, where it crosses the x-axis. That's when x is over here, it's 4, when y is 0. Well, didn't we find out on the last slide that when y was 0, when this was set equal to 0, x was 4? So graphing is just another way to solve this. Okay? So let's look at the equation y equals 1/3 x minus 2. What is the y-intercept? Because that's our first step for graphing. And what is our slope? Good, our y-intercept is -2, our slope is m. So go ahead in your notes, draw your coordinate plane, and make a graph of this equation. And then you're going to be looking for where it crosses the x, and we should already know where it crosses the y because that's our y-intercept. So find out where it crosses the x, and for the answer to this question, give your ordered pair. So your graph should look something like this with your y-intercept on -2 and then up 1/3 because that's your slope, rise over run, up 1/3. So this point right here, x is 6, y is 0. That is the ordered pair. And if we were to go ahead and check that, we would get that x equals 6 when y was 0. So we know that this ordered pair is correct. Stay with me for one last example. If we have (3x plus 7) equals 3x plus 1, how would I graph that? Well, if you're looking at it, it may say that these sides aren't really equal, so that would be a no solution type problem. We should kind of remember this from chapter 2. My other issue would be, what if y equals 6? And I want to find, sorry, that's a 6, not a 0. And I want to find that x-intercept. Well, let's go ahead and graph this one. I'm going to go up 6 on my y-axis because that's what y is equal to. Oh, that's 6. And I'm going to put my point. And remember, if you watched the last video about graphing, when y is equal to 6, I have that straight line at 6. So, is there ever an x-intercept? No. And in fact, we even know that this slope is what? If you will recall from the last video. That's right, 0. Okay? Thanks for watching.